Welcome to Chapter 9, Sustainability in Logistics and Supply Chain Management. In this lesson, we'll look at how logistics decisions, how we transport, store, package, return, and source products, directly shape environmental impact, social outcomes, and long-term business performance. Sustainability is no longer a nice-to-have. It's a core capability for modern supply chains, and it influences competitiveness, compliance, resilience, and trust. Here's what we will cover. First, we'll clarify why sustainability has become so important for supply chains. Then we'll explore the main environmental impacts across supply chain activities and learn how to map the supply chain footprint. Next, we'll move into green logistics practices, especially transportation, warehousing, and packaging, where many of the biggest improvements can be made. After that, we'll shift from a linear take, make, dispose mindset to the circular economy, where value is kept in the system through reuse, repair, remanufacturing, and recycling. Finally, we'll discuss how to measure sustainability performance using the right metrics and reporting frameworks, because what gets measured gets managed. Let's begin with the importance of sustainability. In today's global supply chains, sustainability is a business imperative. It shapes how companies manage costs, meet regulations, respond to customer expectations, secure investment, and reduce operational risks. Sustainability is not a separate initiative sitting beside supply chain strategy. It increasingly is supply chain strategy. So why does sustainability matter so much? First, environmental responsibility. Logistics and transportation contribute significantly to global emissions and pollution, so supply chains are under pressure to reduce their footprint. Second, regulatory compliance. Governments are tightening emissions rules, waste laws, and reporting requirements, and non-compliance can be expensive and damaging. Third, cost reduction. Energy efficiency, optimized routes, and waste reduction often lower operating costs over time. Fourth, brand reputation and trust. Stakeholders remember sustainability failures, but they also reward credible progress. Fifth, customer expectations. Consumers and business customers increasingly prefer responsible companies and products. Sixth, risk management. Climate events, resource scarcity, and disruption risks can break supply chains, and sustainability helps build resilience. And finally, long-term viability. Companies that ignore sustainability may struggle to operate profitably in the future economy. A helpful way to understand sustainability is the triple bottom line: people, planet, and profit. People refers to social responsibility, fair labor practices, safe working conditions, respect for human rights, and positive community impact. Planet means environmental stewardship, conserving resources, reducing pollution, minimizing waste, and protecting ecosystems. Profit is economic viability, running efficient, competitive operations that create value for customers, employees, suppliers, and investors. True sustainability happens when these three dimensions are balanced, because progress in one area can support, or sometimes conflict with, another. What is driving companies to adopt sustainability? Climate change concerns are pushing organizations to cut greenhouse gas emissions, especially in transport-heavy industries. Resource scarcity is another driver. Energy, water, and raw materials are becoming more constrained and more expensive. Regulatory pressure is rising, along with carbon pricing and disclosure rules. Stakeholder expectations are changing. Investors look at ESG performance, customers demand transparency, and employees want values-aligned workplaces. Sustainability can also create competitive advantage by differentiating services, improving reliability, and enabling premium offerings. It opens innovation opportunities in technology, packaging, and business models. And it supports risk mitigation by reducing exposure to disruptions, compliance failures, and reputational harm. Sustainability also has a strong business case. Financial benefits often come from reduced energy costs in warehouses and facilities, lower waste disposal fees through waste prevention and recycling, and improved efficiency through better planning and optimization. Companies also reduce risk, less dependency on volatile fuels, fewer compliance surprises, and more robust operations. Strong sustainability performance can increase brand value and customer loyalty, especially in markets where trust matters. And increasingly, it improves access to capital, because lenders and investors evaluate climate and ESG risks as part of financial performance. Now we move to environmental impact. Before we can improve, we need to understand the supply chain footprint. Environmental impacts don't happen in one place. They are distributed across suppliers, factories, warehouses, transportation routes, product use, and end of life. Sustainability in logistics requires systems thinking. Changes in one area, like packaging, can affect transport efficiency, damages, returns, and emissions. The key environmental impact areas in supply chains include carbon emissions, energy consumption, water usage, waste generation, and resource depletion. In addition, supply chains can contribute to air, water, and soil pollution through operations, chemicals, and improper disposal. Another area that is gaining attention is biodiversity impact, how sourcing, land use, and infrastructure affect ecosystems. Understanding these categories helps us identify where the biggest hotspots are so we can prioritize improvement. Carbon footprint is often the starting point, and it is typically structured using Scope 1, Scope 2, and Scope 3 emissions. Scope 1 covers direct emissions from sources a company controls, such as its own vehicles and on-site equipment. Scope 2 covers indirect emissions from purchased energy, mainly electricity used in facilities and warehouses. Scope 3 includes emissions across the value chain, outsourced transportation, supplier activities, and product-related emissions. For many companies, especially retailers and manufacturers, Scope 3 is the largest share, which is why supplier and logistics collaboration becomes essential. To calculate and report emissions consistently, many organizations use the Greenhouse Gas Protocol. It's an international standard that covers major greenhouse gases such as carbon dioxide, methane, nitrous oxide, and fluorinated gases like HFCs, PFCs, and SF6. These gases are converted into a common unit called CO2 equivalent, or CO2e, so emissions from different sources can be compared. Using standardized methods makes reporting credible, supports benchmarking, and helps organizations set targets and track progress. With the impacts understood, we can focus on green logistics, practices that reduce environmental harm while maintaining service and performance. Green logistics is about smarter decisions in transportation, warehousing, and packaging, supported by data, technology, and collaboration across partners. Transportation is often the largest logistics emission source, so green transportation strategies are crucial. Route optimization reduces unnecessary miles and fuel use. Load consolidation increases utilization, so fewer vehicles move the same volume. Alternative fuels, such as biodiesel, CNG, or other low-carbon options, can lower emissions in certain contexts. Electric and hybrid vehicles are expanding, particularly in urban last-mile delivery. Intermodal transport, using combinations like rail plus truck or sea plus truck, can reduce emissions compared to single-mode road or air. Efficient fleet management, preventive maintenance, and driver training also matter, because driving behavior and vehicle condition directly influence fuel consumption and emissions. Route optimization is one of the most practical sustainability levers because it often pays back quickly. When routes are optimized, organizations typically reduce fuel consumption, lower emissions, and decrease costs, while often improving delivery times through better planning. The enabling technologies include GPS and telematics for tracking vehicles, route planning software that considers constraints like delivery windows, and real-time traffic data that supports dynamic rerouting. The key idea is simple: better decisions, made consistently, reduce waste in motion. Alternative fuels offer another path to decarbonize transportation. Options include biodiesel, compressed natural gas, liquefied natural gas, hydrogen fuel cells, and battery electric vehicles. Each option has trade-offs: infrastructure availability, vehicle range, cost, and upstream emissions all matter. The goal is to reduce the carbon footprint of transportation, and in many cases, reduce long-term operating costs, especially when energy prices and carbon regulation are considered. Warehouses also have a major environmental footprint through electricity use, heating and cooling, equipment, and waste. Green warehousing includes installing energy-efficient LED lighting, optimizing HVAC systems, using solar panels or other renewable energy, and applying green building design standards such as LEED. It also includes practical operational practices like waste reduction and recycling programs, water conservation measures, and choosing sustainable building and packaging materials. The warehouse becomes not just a storage point, but a platform for efficiency. Energy efficiency upgrades in warehouses are often among the highest impact and most cost-effective initiatives. LED lighting can deliver major energy savings, especially when combined with motion sensors that reduce unnecessary lighting in low-traffic areas. Increasing access to natural lighting, improving insulation, and upgrading to smart HVAC systems can significantly cut heating and cooling costs. Energy management systems help monitor consumption, identify peaks, and prevent waste. Many organizations find these improvements have a return on investment in roughly 2 to 5 years, making them attractive from both sustainability and financial perspectives. Beyond reducing energy use, companies can change the energy source. On-site generation includes solar panels on warehouse roofs, wind turbines where feasible, and geothermal systems in specific building designs. Organizations can also purchase renewable energy through mechanisms such as renewable energy credits or power purchase agreements. The result is a reduced carbon footprint and, in some cases, more predictable long-term energy costs, especially valuable in volatile energy markets. Packaging is a sustainability hotspot because it affects material consumption, transport efficiency, and waste. Green packaging focuses on reducing material usage first, then shifting to recyclable or biodegradable materials, and increasing reusable packaging where supply chains can support it. Right-sizing packages, matching packaging size to product size, reduces empty space, which improves truck and container utilization and lowers emissions per unit shipped. Another important step is eliminating unnecessary packaging, especially where it adds no protection or customer value. And sustainability also depends on sourcing, where materials come from and how they're produced. Packaging reduction strategies include lightweighting, using less material for the same function, eliminating extra layers, and optimizing dimensions to reduce wasted volume. Some companies also redesign products or offer concentrated versions to reduce packaging and transportation needs. The benefits are powerful and immediate: lower material costs, reduced shipping costs due to lighter and smaller packages, and less waste at the customer end. Packaging is a great example of how environmental improvements can align with economic performance. Reverse logistics is the set of processes used to manage product returns and recover value. Instead of treating returns as pure cost, companies can implement refurbishment, remanufacturing, recycling programs, and proper disposal for materials that cannot be recovered. When reverse logistics is designed well, it enables closed-loop supply chains, where products, components, and packaging flow back into the system. Take-back programs are one practical approach, especially in electronics, apparel, and durable goods, where recovered products can generate value and reduce environmental impact. This takes us to the circular economy. Traditional supply chains often follow a linear model: take resources, make products, and dispose of them. The circular economy moves beyond that, aiming to keep materials and products in use and reduce the need for virgin resources. For logistics, this means designing flows not only from supplier to customer, but also from customer back to recovery, repair, reuse, and recycling operations. Circular economy principles include designing products for durability and reuse, keeping products and materials in use as long as possible, regenerating natural systems rather than depleting them, and minimizing waste and pollution throughout the life cycle. Compared to the linear take, make, dispose approach, circularity requires a mindset shift. Waste is treated as a design flaw, and value recovery becomes a strategic capability. Circular economy thinking leads to new business models. Product as a service means customers lease or subscribe instead of owning, which gives companies incentives to design durable, repairable products. Sharing platforms enable collaborative consumption, increasing utilization of assets. Product life extension focuses on repair, refurbishment, and remanufacturing to keep items valuable longer. Resource recovery includes recycling and upcycling to extract materials and create new inputs. All of these models have logistics implications. They require reverse flows, inspection, sorting, and inventory strategies for recovered items. Circularity starts with design. Modular design makes repairs and upgrades easier. Standardized components reduce complexity and support reuse. Easy disassembly lowers the cost and time needed to recover parts. Durable and recyclable materials extend life and improve end-of-life recovery. Minimizing material variety helps recycling processes work better. Clear labeling supports sorting, compliance, and safe handling. In other words, circular logistics becomes feasible when products are designed to move through multiple life cycles. Implementing circular economy practices requires several building blocks: reverse logistics, infrastructure to collect and move used products, partnerships and collaboration with suppliers, recyclers, logistics providers, and even competitors, technology enablement for tracking and traceability, business model innovation to make circular offerings profitable, customer engagement, because return and reuse depend on customer participation, and policy support, such as extended producer responsibility rules or incentives that improve the economics of recovery. Now we turn to performance metrics. Sustainability must be measured to be improved. Metrics allow organizations to track progress, identify hotspots, compare performance, and report transparently to stakeholders. The most effective measurement systems cover environmental performance and ideally link results to business outcomes like cost, service level, and risk. Common sustainability metrics in logistics include carbon footprint in CO2e, energy efficiency such as kilowatt hours per unit handled, water consumption per unit, and waste diversion rate, how much waste is prevented from going to landfill. Recycling rate is another important indicator, along with sustainable sourcing percentages and the percentage of renewable energy used in operations. The purpose of these metrics is not just reporting. It's to guide decisions, investments, and operational priorities. For carbon, companies often track total emissions in tons of CO2e, as well as intensity metrics like emissions per revenue, emissions per shipment, or emissions per mile. Intensity metrics are useful because they show improvement even as the business grows. Organizations also measure reduction versus a baseline year and progress towards stated targets, because a number without a target doesn't create accountability. Waste metrics typically include total waste generated, the portion diverted from landfill, and the recycling rate. Many organizations also track hazardous waste separately due to higher risk and stricter regulation. Waste per unit produced or handled helps identify efficiency improvements, and zero waste progress indicates how close an operation is to minimizing landfill disposal through prevention, reuse, and recycling. To report sustainability performance credibly, organizations often rely on recognized frameworks. The Global Reporting Initiative, or GRI, supports comprehensive sustainability reporting across economic, environmental, and social topics. CDP, formerly the Carbon Disclosure Project, focuses on climate-related disclosure and helps organizations standardize how they report emissions and risks. Science-based targets provide guidance for setting emissions reductions aligned with climate science. And ISO 14001 supports environmental management systems, helping companies establish structured processes for continuous improvement. GRI standards are widely adopted and include universal standards, covering foundational principles, general disclosures, and management approach, along with topic-specific standards in economic, environmental, and social areas. The value of GRI is that it encourages organizations to report not just outcomes, but also how sustainability is managed, governed, and integrated into decision-making. Science-based targets, often referred to as SBT or SBTI, align corporate emissions goals with climate science, specifically pathways consistent with limiting warming to 1.5 degrees Celsius. These targets typically cover Scope 1, 2, and often Scope 3 emissions, and may include both near-term and long-term goals. Third-party validation increases credibility and signals real commitment, which matters to investors, customers, and regulators. Life Cycle Assessment, or LCA, provides a cradle-to-grave view of environmental impact, from raw material extraction to manufacturing, transportation, use, and end of life. LCA helps identify hotspots that may not be obvious. For example, a packaging change might reduce waste but increase emissions due to heavier material, or a product redesign might reduce manufacturing impact but increase use phase energy. LCA supports better trade-off decisions by showing the full system impact. Sustainability is a continuous improvement journey. Organizations should set ambitious targets, monitor and report regularly, and engage stakeholders to maintain momentum and credibility. Innovation and technology help identify new opportunities, but progress also requires supply chain collaboration, because major impacts often sit outside one company's direct control. Transparency and accountability are critical. If performance is measured and shared, it becomes easier to improve and harder to ignore. Sustainable procurement is a major lever because suppliers strongly influence Scope 3 emissions and social outcomes. It includes assessing supplier sustainability performance, using green procurement policies, and applying ethical sourcing standards. Many companies also prefer local sourcing, where it reduces transport emissions and supports community development, although they must balance this with cost and capability. Supplier development programs help raise performance through training and joint initiatives, and certification requirements can formalize expectations. Supplier engagement turns expectations into action. Sustainability scorecards help track supplier performance and make sustainability visible in supplier relationships. Joint improvement projects create shared benefits, such as reducing packaging, improving energy efficiency, or increasing recycling. Knowledge sharing and capacity building are essential, especially when suppliers lack resources or expertise. Incentives and recognition can motivate change, while transparency requirements improve data quality and enable better decision-making across the chain. Technology increasingly accelerates sustainability. IoT sensors can monitor energy use, temperatures, and equipment performance in real time. AI can optimize routes, warehouse slotting, inventory policies, and even procurement decisions to reduce waste and emissions. Blockchain can enhance traceability, supporting responsible sourcing and credible reporting. Digital twins allow organizations to simulate supply chain changes before investing, testing network redesign, fleet changes, or facility upgrades. Analytics turns data into insights, and collaboration platforms help multiple partners work from shared information. Regulatory compliance is another critical factor. Emissions regulations may limit vehicle standards, fuel types, or facility emissions. Waste management laws govern disposal, recycling, and hazardous materials. Extended producer responsibility policies push companies to take accountability for products and packaging after use. Carbon pricing can increase the cost of high-emission operations and make low-carbon investments more attractive. Reporting requirements and industry standards also expand over time, so proactive compliance can become a strategic advantage. Sustainability in supply chains is shaped by stakeholders. Investors evaluate ESG performance and risk exposure. Customers express preferences through purchasing decisions and supplier requirements. Employees want workplaces that reflect their values and protect their well-being. Communities care about local environmental and social impacts, such as traffic, noise, jobs, and development. NGOs influence public expectations and highlight risks. Regulators enforce compliance and set future direction. Effective sustainability strategies consider all these perspectives and communicate progress clearly. Of course, implementation comes with challenges. Sustainable solutions can require higher initial costs, even if they pay off later. Global supply chains are complex and hard to coordinate, especially across multiple tiers of suppliers. Measurement can be difficult due to limited data quality and lack of universal standards. Companies face trade-offs with objectives like speed, flexibility, and cost. Supply chain visibility is often limited beyond direct suppliers, and sustainability requires behavioral change, new routines, new incentives, and sometimes new ways of working. Overcoming these barriers starts with executive commitment because sustainability needs leadership support and resources. Building a clear business case helps align sustainability with operational and financial priorities. Phased implementation reduces risk by starting with quick wins and scaling proven approaches. Partnerships and collaboration expand capability and share costs. Technology investment improves measurement, optimization, and transparency. Training and awareness help people understand why changes matter and how to execute them. And celebrating successes reinforces progress and keeps engagement high over the long term. Best practices include integrating sustainability directly into supply chain strategy rather than treating it as a side project. Set clear targets, measure and report consistently, and engage stakeholders early and often. Innovate continuously, because technologies and expectations evolve quickly. Collaborate across the supply chain, especially for Scope 3 emissions and social standards. And communicate transparently. Credible reporting builds trust and reduces reputational risk. Looking ahead, several trends will shape sustainable logistics. Net zero commitments will expand and become more detailed, including Scope 3 requirements. Circular economy adoption will grow, supported by new regulations and customer models. Regenerative practices will gain attention, moving from do less harm to create net positive impact, especially in land and biodiversity. Climate adaptation will become essential as extreme weather disrupts routes, facilities, and supply availability. Biodiversity protection will rise as a reporting and operational priority. Social sustainability will receive more focus, including labor rights and ethical sourcing. And technology acceleration, AI, automation, and advanced analytics will push faster and more measurable change. To summarize, sustainability is essential for long-term success in logistics and supply chain management. It starts with understanding environmental impact, especially emissions, energy, water, and waste, and then applying green logistics practices across transportation, warehousing, and packaging. It expands further through circular economy approaches that keep materials and products in use and reduce waste. And it becomes actionable through measurement and reporting, using strong metrics, credible frameworks, and continuous improvement. Most importantly, sustainability must be integrated across the supply chain. When organizations align people, planet, and profit, sustainability becomes not only a responsibility, but also a source of resilience, innovation, and competitive advantage.